angle between line and plane. So in this video, we want to discuss about angle between the line in red color with the plane in blue color. So how to find this angle theta? Now, let's say we have a line and a plane with the equation like this. So if we want to find the angle between the line and the plane is theta. How to find this angle theta? Actually, before you find the angle theta, you must know this angle, alpha. So to find alpha, it depends on the normal and the direction of the line, vector B. So to find angle alpha, we use scalar product. So by using scalar product, you can find the angle alpha. Then if you have alpha, you can find the angle between the line and the plane minus by 90. So this is the way we find angle between the line and the plane. Some books, our textbook, school textbook, they give you this relation. Instead of using cos theta, they straight away substitute with sine. Instead of cos alpha, they write sine theta, and theta is the angle between the line and the plane. Actually not easy to use. I would prefer you using this relation. Find the alpha first and then minus by 90. And you want to know how to get this relation between sine theta and cos alpha. From here, theta equal to 90 minus alpha, you take sine both sides and then use the compound angle formula for sine A minus B, then you get the cos alpha. Okay, so there is the relationship between theta and alpha here. Now, in this example, we want to find the angle between the plane and the line. As usual, we use a diagram to help us to understand the question. So you need to find out angle between the normal and line first. Angle between the normal and the line. So by referring to the equation, you can write out the direction of the line B is this vector, and then the normal from here, from this equation. So now you have the normal, you have the direction of the line. You can use scalar product to find the angle between the line and the normal. So theta is 24.7. So remember, this theta is not angle between the line and the plane. It is between, you look at here, B and it is between vector B and vector N, which is referring to the line and the normal. So the angle that you want is this part. Is equal to 90 minus theta. So the answer is 65.3. Another method, if you refer to our textbook, is say if beta is the angle between the line and the plane, then take sine beta. Sine beta equal to the cos theta. So straight away they use this relation. Sometimes they change the n, they take the unit vector. So you can take unit vector also. Then this part is 1, magnitude is 1, so simplifying to this format. So some students want to memorize this, and then straight away they calculate the value for theta, and this is the answer. But I have to remind you, if you want to use this relation, make sure you really understand. And actually there is a condition. The condition is this part is a positive one. The cos theta, the value is a positive one. If there is a negative here, then you cannot straight away do it this way. Later on we will discuss about this. Now we want to discuss one special case when alpha is more than 90 degrees. So when you do the calculation b dot n, sometimes have a negative sign. When you have negative sign means alpha, the angle between the line and the normal, is an obtuse angle. Okay, here. Okay, this thing happen. All of you must know that the diagram that we use now, we just simply draw. We assume that the normal is moving up, the direction of the line is going up. But actually, who knows? The normal that you calculate is the direction is going down, opposite direction. So normal not necessarily going up like this. It can be at the other direction going down. So if that is the case, in scalar product, you see the vector going up here, divert down here. So the angle is in the red color one. So this is the obtuse angle. When it is an obtuse angle, how to determine the angle between the line and the plane? Theta here. So from the angle in red color here, if you want to find theta, actually is alpha minus 90. Alpha minus 90. So we need to do a little bit of changes here. If alpha is obtuse angle, we use alpha minus 90. And the relation that you have in your textbook, you need to change also. That's why just now I say when you want to use this formula, change cos alpha to sine theta, is only correct when alpha is acute angle. If alpha is more than 90 degrees, you need to do some changes. From this relation, you notice that you need to put a negative sign in front. So now look at this example. This is equation of the plane, and this is the equation of the line. Now we want to find the angle between the plane and the line. This diagram can help you. So if you want to find the angle between the line and the plane, you must know the normal, you must know the direction of the line. The direction of the line can refer to the equation here, and this part 2i minus j is the vector that parallel to the line here. Now we want to determine the normal to the plane. We refer to this equation. But this equation, you don't have the normal here. You must know that equation of the plane can be written in different form. Okay, this is parametric form, vector equation that related to normal, or the Cartesian form. I think most of us more familiar with the equation in number 2 and 3, and this type of equation you can straight away identify the normal. How about equation in parametric form, number 1? So here you must know the meaning of vector A, B, and C. So A is the position vector of any point lying on the plane. BC are any two vector lying on the plane. So you know this, then you can use BC. You take the cross product of BC, then you will get the normal to the plane. The cross product of vector BC is perpendicular to B, perpendicular to C, and of course it is also normal to this plane. So now you need to carry out the cross product B and C. Okay, so refer to this equation. This part is B, this part is C, or you can say this is B, another one is C, doesn't matter. And by using cross product, this is the vector, this is the normal that perpendicular to the plane. So now we have both the direction of the line and also the normal. So we can find out the value of the angle theta using scalar product. So cos theta have a negative sign here. So with negative sign, you know, the answer must be a obtuse angle. The earlier part, we always refer the angle between the line and normal is an acute angle. Now it is an obtuse angle. How can this happen? Let me explain. You must know that all the diagram that we draw here are we just simply draw. We assume that the normal is going up, the line in the direction going up also, but actually who knows? The normal is going down, the opposite direction. So normal not necessarily going up. The normal can going down, going down. So it's going down, and if the line is going up, so the angle between the two line, the two vector, is in the label in the with the blue color. So this is the angle 140.8. So now if you want to find the angle between the line and the plane, you need to minus 90 degree if you refer to this diagram. So angle between the line and the plane is 50.8.